each split and say, oh, we have found a Nyasha 5 times. We have also found a Robert 2 times. And then on this second split, we've also found a Nyasha once, and we found a Robert 7 times. On this third split, we found a Robert 2 times, and we found a Nyasha 4 times. So now we take the unique keys that we found, the similar keys, and we group them in what we call a merge. So we have Nyasha 4 times here, Nyasha 2 times here, Nyasha 3 times here. And then we have Robert 2 times here, Robert 3 times here, Robert 7 times here. And then when we reduce, we are now saying, okay, this whole block is a Nyasha block of the people named Nyasha. So we have Nyasha how many times? 4 plus 2 plus 2. We have Nyasha 8 times. This is what we call a distributed file system. So this whole process of sorting, sending, and merging can happen a number of times. And it's called a shuffle because it's iterative. It happens a number of times until we sort all the names at Chinua University with the number of people in this lecture. We have Tendai, Leslie, Courage, Aaron, Michael, Mfaro, me, until we sort everyone. So we have this process iteratively until we have a distributed file system. So that's how MapReduce works. I don't know if you have understood how the concept of MapReduce works because it's very, very, very important. Can we say MapReduce? Hello? If you can please just let me know who does not because I am just going to move forward if no one answers. I will assume silence, I will assume you have understood. Okay. So in real life, this is an example. We have a data chunk here, and these are the unique identifiers or the unique keys they found, and this is the final result. The keys have been mapped. The tamona panapa, tkamona futi panapa, tkamona futi panapa. So we have the 1 1 1 1 pesepa 1 equal. And this is the mapping to the shuffling stage of times. And so the tazomwana 4 times. So what is our final result? The 4 times set to mat cat advac. So this is a distributed file system. It's then put into a different framework for processing. These are the advantages of MapReduce. This is what will be done in class practically. There's a group that is going to do this presentation. I'm going to upload my topics in a presentation. At Shazuita, like you said, would you want the first week of September, which is fine by me, as long as it doesn't clash with another presentation from another class. So that's it. I'll have gone on to explain Hadoop ecosystem, but we'll also have a group presenting on Hadoop ecosystem. And in brief, this is how our data, it moves from the database into a Hadoop distributed file system through a streaming technique. This is a streaming technique, the scope. This just means SQL plus Hadoop. Right? So we're moving data from a structured source, SQL database, maybe Oracle or Access, and then through scope into a Hadoop distributed file system. Or we are moving data, streaming data into types of data. In the funnels with some data and structured, they're all same structured. My facts and figures or my images and videos. If the images and videos if it's data from Facebook or WhatsApp, I use a streaming technique called Flume, because That's the one that takes unstructured data and move it into a Hadoop distributed file system. And when it moves to a Hadoop distributed file system, it is processed by a framework that is called MapReduce and stored in what we call a Hadoop database. After this information is processed, it's stored in a Hadoop database, known as HBase. And when I want to query this HBase, I can use one of these techniques. Mahout is used for machine learning. Pig Latin is used for people who understand scripting languages like Python and things like that. Hive is used for people that understand SQL, the traditional way of querying databases. So these techniques are all for the same purposes, but the difference is what are you talented at. So you don't really need, when I choose a big data analyst in Hadoop ecosystem, it doesn't mean you need to know Hive, Pig Latin, Mahout, JSA, and you just need to know what you want to use. Hive, if you're strong in SQL. Pig Latin, if you're strong in scripting languages like Vana, Python, or if you're strong in Scala, which is a functional programming language. Mahout, if you're strong in machine learning. And then Uzi is for workflow. It's the one that controls this information to make sure the data is moving in the correct channel from a source through a streaming channel to the Hadoop distributed file system. Ndo panopinda nani na MapReduce panapa kusvika tawana processed data redu in a Hadoop database. And then when you want to query that data in a Hadoop database, you use Hive if you're strong in SQL, Pig Latin if you're strong in Python, Mahout if you're strong in machine learning. So Uzi makes sure that this process is like that. Then Zookeeper, technologies in a Hadoop ecosystem are many. So Zookeeper is there to make sure that from the name itself, Zookeeper, are able to oversee that animals are behaving, or the Hadoop ecosystem, the Zookeeper is the keeper, is the gatekeeper, is the lion, who makes sure that Hive, you're not doing Basara Mahout. Mahout, you're not doing Basara Hive. Or Pig Latin, you're not taking resources. Remember, networking, kuna inonzi bottleneck. System yekutokavhura pamachine pako handiti, for example, panapa ndakavhura let's say Slack, handiti ndikavhura Slack inogona kutora ma-resources on this machine, a lot of resources from this machine. So Zookeeper is there to make sure that resources are distributed fairly, nodes are getting the data that they are supposed to get. So that just brings me to the end of this class. Last PowerPoint is just general. Remember, I said it's for you to understand just my network consideration. The type of memory, the network line. I created this slide for people who want to know what the benefit of what the learning unit say, one unit say, and this CD, no shanda say DVD, no shanda say cache memory, what is it? Primary memory, what is primary memory, what is main memory, what is RAM, what is ROM. You need to understand all that if you are a big data analyst, so that you just know how you're going to store your data. So this just brings us to the end of this class. There are some topics. This topic and then topic 6. So 4 topics we've covered. They're just beginner topics. You're going to do them as my presentation. So the delegation of my topics, how we are going to present, you'll do your write-up. Every topic has a practical demonstration as part of your practical coursework mark. So you'll do your write-up and then your practical video and the presentation. power Batanga class, so the power is just back on. So you will do your practical write-up, and then you will do your practical demonstration, which will contribute to your practical coursework bank, and then the presentation. So every topic you'll get as a practical demonstration. So that's it. I hope we have brought the Big Data Analytics degree program into perspective, and you've understood how everything is interconnecting. And this course ideally is supposed to be many courses split, because the streaming analytics, the whole technology on its own, the computational analytics, the whole technology on its own, states Maita, computational analytics, but we tried to bundle it in 4 days, and we tried to do it because we are just doing at a very low level. So I hope you just catch something. You choose your stream. Do you want to be diagnostic analytics, descriptive, predictive? And you also choose your field of trade. Do you want to be an analyst in mining, in agriculture, in what? I myself, I major in streaming analytics as a technology, and I am a predictive analyst, and I am into robotics. So you see, you need to define your trade. Good, okay, this is where I start and this is where I end. Here and there, I do take a project outside the robotics field or electrical engineering field or computer science field. Of late, I've been working with my telehealth organizations and telehealth systems is part of my research. But you need to define your field, you need to define your trade, and you need to define your domain. So from me, that's it. I don't know if there's anything else you want to know. That was just my advice. My last advice to you is we now start competing in the same domain, because after this, we already are competitors in the space of big data analytics. Nothing will stop us from competing, I hope. So that's just a tip. It was nice having you guys as a class. I hope you also enjoyed having me here. We'll meet again for my presentations. I think that's it from me.
Thank you.
Thank you.
Thank you, engineer.
Thank you, engineer.
Thank you, engineer.
Thank you, engineer.
Engineer.
Thank you, engineer.
Thank you, class.